Okay, yeah, thanks for having me. I'm starting with something delicious, namely with Krapfen. And I've been told that you have a very similar name for this dish here, this donut without a hole. Who knows Krapfen? Yeah, of course, everyone. So the thing is, it's a donut without a hole in the middle, and this is for a reason, because the hole would be counterproductive. It's the case that normally it's filled with jam. And people consume it all over the year, but especially during Carnival. During Carnival, this is really consumed a lot. And you know, during Carnival, people try to be funny, haha, and so some of those people try to exchange the jam by something else, by mustard. It's really a no-go. They just take one of the Krapfen from the plate, just one, exchange the jam by mustard, and put it back. And if you have bad luck, if you are the person who fetches the mustard Krapfen, then you really have a bad experience. So I would not recommend it, it's not nice, but yeah, sometimes people are doing something like this. And I think this simple example shows that sometimes a small change can have a huge impact. And it's about the same if we try to exchange something like Redux by a more simpler state management solution, by a very lightweight store. And this is the big question I want to answer today. What happens if we exchange something like Redux, something we all know and love, by simpler means of state management? So what do I refer to when I'm mentioning something like a lightweight store? Well, for me, a lightweight store is just something like a class or a service that offers some methods. And every time I'm triggering a method, something is done. The store is fetching some data or storing some data or calculating something. And this is most of the times done in an asynchronous way, but it also can be done in a synchronous way. Nevertheless, after we have the result of this operation, we have some new state that flows down to the component, or to be more precise, to the component's view. With some means, by means of an observable or a signal, it flows down. And it looks like that more and more people are adopting this lightweight style of state management out there. If we look into the different communities, we find a lot such lightweight solutions. And one of those solutions we have in the Angular space is the new NGRX Signal Store. To answer the question, how does moving over to a lightweight solution change your architecture, I've prepared several things. I want to get started with a baseline architecture, and on top of this baseline architecture, I'm explaining what happens when we introduce a lightweight store. And for this, I'm answering several questions like, how large should the store be? Or where to put the store? Or what to do with global and or local state? And another question is about preventing cycles, redundancies, and inconsistencies, something Redux really shines at, doesn't it? Before we start, let me introduce myself. I'm Manfred. I am a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. In this role, I'm doing a lot of trainings and consulting. I'm also quite connected to the Angular community. I live in Austria, where we have Krapfen, as we meanwhile know. I do a lot of stuff in Germany, and I'm always happy to work together with people around the globe, like people here in Serbia. Okay, let's get started with our baseline architecture. For my baseline architecture, I'm using NX, I'm using Angular, obviously, and I'm using the new NGRX Signal Store. And when doing an architecture for a larger business application, I really like to slice it into verticals. Into verticals, parts that don't need to know much about each other. If we look into strategic design from domain-driven design, those verticals are the so-called business domains. That means we are looking out to the real world, you know. The real world is where the pizza boy comes from, and there we identify business domains that don't need to know much about each other. So in my case, it's always about booking flights. I have a booking vertical, I have a boarding vertical, and I have this shared vertical that is for everyone, that provides general purpose shared stuff. And after defining those business domains, those verticals, I'm filling them with modules. And here I'm going with the module categorization the NX team gave us. They told us, please subdivide your modules at least into 4 categories. The first category is the feature category. It contains smart components implementing your use cases. The next category is the UI category. It contains dump components, highly reusable components, and to make them reusable, they can know much about your use cases. Otherwise, they wouldn't be reusable. Think about a date-time picker or a data grid. Then we have the data layer with data structures, but also with services communicating with the backend. And we have an utility layer with general purpose utility functions like translations or authentication, dealing with dates and times and so on. The benefit of such an architecture is it brings a lot of order. We have less discussion about where to put something and where to find something. Plus, we can introduce access restrictions, like everyone is only allowed to navigate top-down in order to prevent cycles. I think the more important restriction is this here. This is where I am coming back to my business domains and verticals. This restriction tells us that one domain is only allowed to talk with its own stuff and with shared. So booking can only talk to booking and to shared, boarding can only talk to boarding and to shared, but booking and boarding and all the other business domains cannot directly interact with each other. And this assures that the first team can change something here without breaking something there. So this architecture I'm normally implementing with NX. There are several options, but I really like NX. And NX gives me a lot of ingredients for this, like modularization. I can enforce that this library is not allowed to access that library, something we need for our matrix to ensure that this part can only talk to that part and so on. In NX, we need to do this on a per library basis, and that's why all those rectangles you've seen before, let's go back, all those rectangles here, all those cells become a library of their own when we go with traditional NX. We have incremental CI/CD in NX. That means only stuff that has been affected by a change is rebuilt, retested, relinted. We have a build cache so that I don't need to build something you build. And we can do everything in parallel in the NX cloud. This also speeds up the whole CI/CD. So some people say, well, I really like NX, but I don't want to have that many libraries. And that's why this guy here, perhaps you have seen him on this conference, has implemented quite a nice open source project. It's called the Sheriff. And the Sheriff is doing basically the same in terms of restrictions. What can I access from here? But in terms of folders on a per folder basis. And so I'm just switching out this little part of the NX story for Sheriff. The remaining parts come from NX, but for modularization, I meanwhile like to go with Sheriff because it's more lightweight. We can do the same on a per folder basis. We don't need that many libraries. So let me show you a demonstration for this baseline architecture. Here I have several apps in this, no, not here, but here. I have several apps in my NX workspace. And when we drill into those apps, yeah, I just have flights and miles. In a real-world project, we might have more apps. And I have some libraries, at least one that is shared. When I'm drilling in here to flights, then you see that I have subdivided my flights application into business domains, like check-in, luggage, ticketing, and shared. And if we drill in here to ticketing, we see we have a feature layer and a data layer. So this is more or less resembling the matrix we've seen before. We have the domains, the columns here, and the rows, the layers there. And if I drill into my feature booking, then we see that we have flight search. And there we see two interesting things. First of all, if I try to grab over to another business domain, to something I'm not allowed to access, Rainer will hit me on my fingers. At least Rainer's implementation, Sheriff, will hit me on my fingers. It will tell me, hey Manfred, what do you think you are doing? You are in the domain ticketing in a feature, and you don't have any clearance for the domain luggage. So grabbing over to luggage is forbidden. It's really forbidden. I cannot access a different domain. It's like going into a different building and taking something out of the fridge. It's not considered polite in most countries, I know. So no broken windows here. By the way, this can be enforced by linting, and so if you check this linting rule before your source code is merged, you don't even get broken windows checked into your base. Another thing that is interesting here is that I'm going with a lightweight store. It's a Signal Store. I'm calling it Booking Store. And as you see here, the store just gives us properties that flew down to the view, properties in the form of signals, and we get some methods we can call to trigger something above there. A synchronous operation, but most of the time it's an asynchronous operation that does something and then populates our signals. So it's really straightforward. It's more or less a service with signals and methods. So this is a small change when we compare it to Redux. However, it has several consequences. The first consequence is the size of such a store. People are wondering how large should it be. And to be honest, as such a lightweight store contains everything we need for one feature, normally we break it down to a feature level or even to a sub-feature level. Because such a lightweight store is just a class, holding some state, holding some methods, providing some computed properties. And as everything is together here on a feature basis, we can only model it on a per feature level. It would not make sense to have one class with 200 properties for several features. So we break it down to the feature level or even to the sub-feature level if the feature level is too huge. And this is also a big difference to Redux, where we have a huge store containing everything and where the parts of the store are spread across several files, a file with an action, a file with reducers, a file with effects. Everything that belongs to a feature is in here. So the second question is where to put the store. And this is where I'm coming back to my leading theory with layers and verticals. When we think about Redux one more time, the answer is quite clear. In Redux, we go with feature slices. We have one state slice per feature, and naturally this feature slice fits into our feature layer. And sometimes we pull it down to the data layer. This is also something the NX team is proposing, because there might be the case where several features of the same domain need the same data. Then we just pull it down. So when it comes to Redux, it's easy. When it comes to lightweight stores, it's not that easy. A lightweight store could live on a component level. In this case, we do a very local state management, just for this one component. If you remember, this is more or less what we also do with the NGRX component store. That's why it's called the component store, isn't it? But we can also co-locate such a lightweight store with a feature. In this case, all the components of the feature can consume this state. We can also put it on the data level if we have several features in the same domain that need to access the same state. In this case, this store will be exposed. That means that Sheriff will allow us to access this piece of code within the other data layer. We can put a store on a utility layer. We don't do this every time because there are a lot of utilities out there that are stateless. Working with dates is quite often stateless. But if you think about authentication, well, after the user has authenticated, we have some state to manage, and that's why we can also have some states there and also some stores there on the utility level if you need it. And the last place might come as a surprise. It looks like breaking a rule. We can even place such a store on the UI level, on the level of dump components. And now you might say, well, this is something we should not do because there is the general rule that a dump component should not have access to the store. And this is right. They should not have access to the store, especially to the global store or to a feature-related store. Because a dump component should be independent from a feature, because only then it's reusable. So it's a no-go to give a dump component access to something concrete like a feature-level store. However, as an implementation detail, a dump component can have its own state and so its own store. Just imagine a very complicated scheduler component with a weekly view, a monthly view, a yearly view. You have a lot of subcomponents there, and you have a lot of state, all your dates and so on. And of course, you need to manage this state somewhere, and this can be done within a store, but as mentioned, this store is an implementation detail. We don't publish it to the outside. So at the end of the day, we see a lightweight store can live everywhere. It can be on a component level or on a module level, and it can be exposed from the module, but also hidden inside, like an implementation detail. And for this, I want to show you a further simple example. In this case, I have my booking store here on the level of my feature. It's the feature booking. Flight booking store, here we go. And here I'm using a very nice feature of the Signal Store. Normally, you would expect something like setting up state, setting up methods, setting up computed signals. But the Signal Store has a really clever API that allows us to combine all those low-level features to high-level features. And this is what I did there. I told myself, hey Manfred, you need a lot of CRUD use cases, and that's why I implemented my very own with data service feature that just allows me to connect a data service like my flight service. Of course, it needs to follow a given interface. I also have here some data for the filter when I'm searching for flights, and that's it. Because of this, by the way, I'm getting filter from for free. It's really statically typed, which shows how smart this extension system is. If I'm typing in here something that was not defined on the other side, the compiler tells me, hey, don't do this. So, you know, everyone is hitting me. Rainer is hitting me, the compiler is hitting me, but it's for the better. I'm also getting an entities property, and I'm getting functions like load and update filter, update selected, just by this high-level feature. I think Alex Otrushko will tell you more about this very exciting topic in the afternoon. Okay, so this is one store. This store is located at the feature level, but we have also a store in the shared slice, in the shared vertical of our application. Within util authentication, it's here the authentication store, and yeah, you know, this application is just for user 1. User 2 gets a different application. Just kidding, it's just for the sake of demonstration. But here I'm using a low-level feature like managing this or that state, defining this or that methods or computed properties. So we really have them on different levels, and that means we need to orchestrate them somehow. Speaking of orchestration, what do we do if we need data from different levels, let's say from the feature level and from the utility level? Well, this really can be the case, because when dealing with lightweight state management, we deal with a lot of tiny stores. and somehow we need to orchestrate them. And what I like to do here is I like to introduce a common feature service that takes something from here, takes something from there, and combines it. And the nice thing, thanks to signals, this is really easy, because signals are a general purpose building block in Angular. I can take a signal from this store, I can take a signal from that store, and combine it via a computed signal. It works seamlessly together, even though it comes from different stores. Angular just does not care. So some people, and this is also doable, make one store access another store, something like this. And this is completely fine, but in this case you need to take care that you don't end up with a cycle. If you follow the rules of layering, you won't have any cycles. If you say, well, a feature store can only access a domain store and or a utility store. So as you know, several roads lead to Rome, as people say. Let's talk about the last thing. What's about cycles, redundancies, and inconsistencies? Something Redux really shines at. Well, when we go with lightweight stores, we have layering, or we should have layering. This is preventing cycles, because one layer is only allowed to access layers below. We have this strategy where one store is not allowed to access other stores. Or if we allow it, then we have to make sure that one store is only accessing stores on lower levels, which comes back to layering. And we have the Redux DevTools. And they are really vital there, because even when you go with Redux, you cannot assure that one team is not adding a redundancy. You have different teams, they have different feature slices, so you could have a redundancy. But the possibility of looking into the store, of finding out what's already in there, really helps you to prevent or to detect inconsistencies. So if you liked this presentation, then pull out your mobile phone and make a picture from this slide. Here you'll find a hyperlink to a free ebook where we have meanwhile 4 chapters about the Signal Store, about how to use it, how to extend it, how it fits your architecture. And we also have a lot of further discussions in there about your Angular-based architecture. It's meanwhile in the 6th edition, it was enhanced quite a lot since we published it back then before the pandemic. You know, the pandemic is the new way of expressing time. Before we had before Christ and after Christ, now we have before the pandemic and after the pandemic. Okay, cool. So let me conclude. What did we see today? Well, we have seen that lightweight stores have the size of a feature or a sub-feature. We have seen that they can live everywhere, even on the level of a dump component. They can be orchestrated by a feature service, and they can leverage layering to prevent cycles. And last but not least, you should use the DevTools to look into your stores and to find out about inconsistencies and about redundancies, or even use it to prevent it. And there is one last thing I really want you to remember. It's more important to everything else. Please never, never, ever put mustard into your Krapfen. That's really a no-go. You are a bad person if you do something like this. So thanks for having me. Here you'll find my contact data. Follow me on Twitter to stay in contact, and please find my slides and examples on my blog at angulararchitect.io. Thank you.
Thank you.